To be completely honest, if we were in school, I would have introduced this topic of graphing polar equations by using GeoGebra. This link is available to you. So if you want to do a split screen like I'm doing and want to really explore and see where this is all these graphs are coming from, feel free to do exactly as I'm doing and follow along. Now, for GeoGebra, when we type in an equation, so we're going to focus on circles in this video, you would have to type in a number and then cosine or sine of some angle. Instead of using theta, they want you to use t as the variable. So I thought for our first circle that we would look at, we would type in, Spencer, can you be quiet while mommy does her video? Probably not. You will notice that I typed in 2 sine t. Now, what I would like for you guys to do is put your finger on that green point that is at the origin right now and watch what happens as you move along the curve that's created for 2 sine t. Notice when we are at pi over 2, we are at the maximum of this sinusoid. Note that the R value from 0 to pi over 2, so that green line represents the changing of the angle. So notice that if I'm over here, I'm at pi over 4, but notice what's happening. When you are going from 0 to pi over 2, that angle is getting larger and larger and larger, and your R value is also increasing until it hits the max. Now, from pi over 2 to pi, we still have a positive R value as the angle is increasing and we are entering quadrant 2, but notice the R value decreases in the same way that it grew from 0 to pi over 2. It's like, growing. It's now decreasing in a similar fashion. Now, once we return to pi, you will notice you have completed this circle because from pi to 3 pi over 2, the R values are now negative. So watch that green line as I enter quadrant 3. You'll notice that those R values are the same positive R values we got from 0 to pi over 2. And that's why you go over the points that you created. And then notice that by the time you get to 2 pi, you have created now actually 2 full circles. Now, you can change this up by changing this to cosine. You can play around with any number in front, but you're going to see the same thing happen. Let's see if I can change this easily. Sometimes I struggle to change this when I'm using the split screen, but if you can maybe go into the front of this, I'm going to struggle to do this, and now you're just wasting your time trying to watch this video of me looking like I know technology, but I don't. But anyway, you can click in that grid. It's kind of hard for me to do, but you can put a negative in front and just see how that -2 would still give you a similar graph. But remember, it's going to now decrease first. So you would see your R values. Gosh, I really want to show you this. Let's do this. Let's try to refresh this. And let's see if it works for me. Let's zoom in into the graph. I'll just delete it. Let's just do this. I mean, we have all day, right? What else do we have going on? There we go. And then I can hit return. And then notice if you go back to 0, so take that green point and go back to 0, you'll see that now from 0 to pi over 2, the R values are negative. So note that the solid green line is where we're at with the angle, but notice that we have to go to the other side because the R value is negative. Now, when you hit pi over 2, again, we're at this maximum R value. Though it is negative, that is still distance-wise the furthest out you go for this graph. Then notice to go to pi, we're still negative R values. Remember that the solid line is where the actual angle is, but we're using the dashed line because our R value is negative. Oh, I just moved that, so that's going to mess everything up, but you guys get the idea. And so that is circle.